So today, me and my partners are going to be teaching you about augmented and regular matrices and how you can add and multiply and also subtract them. So what is a matrix? It's basically like a list with a column and rows here, like that, with numbers in them. So there are different types of matrices. There's one called a row matrice, which just has one row, like that. And then there's a column matrice, which is one with one big long column and only one column in like multiple rows. So. And then there is a square matrice, which means that its number of rows and columns is equal. And then there's a zero matrice over here, which means that all of the numbers in it are zero. Yeah, so that's that.
Okay, so adding, subtracting matrices. You want to be honest, if you have no clue when you need to add and subtract matrices, this is how you do it when you do need to do it. Now here's Smirk sucks. Here's something to know. You cannot do it whenever the dimensions are the same, right? So as Brett was just talking about, you have rows and columns. This makes it something kind of like a 1x3 situation. 1 row, 3 columns, right? And so you can only add and subtract matrices the same number of rows and the same number of columns. You can't do a 3x1 plus a 1x3, that doesn't work. You need a 1x3 plus a 1x3. Now once you do have the same dimensions, you have these cool, funky little numbers in here. These numbers have no meaning at all, just writing down random numbers because I'm cool. And so you have two matrices, these are both 2x2 square matrices, right? And so to add them together, you add up these numbers simultaneously. And so you get equals one big new matrice, right? And so you add up 1 and -3, which is going to be -2. You add up 5 and 7, which is going to be 12. You add up 3 and 8, which is going to be 11. And you add up 6 and 0, which is 6. And so these two matrices equals a matrice with this. Sorry, I'm sick. And so then, but like, what if you want to like subtract it, right? And so to subtract these two, you do the exact opposite. We still have these numbers, but instead of adding the 1 plus -3, we subtract the 1 plus -3, and I'm really bad at my math. What is 1 minus -3? It's 4. Yeah, I knew that off the top of my head. So then if we subtract these two matrices, we get 4, 5 minus 7 is -2, 3 minus 8 is -5, and 6 minus 0 is 6. It's a 2. See? And so to add matrices, you just add up the numbers. To subtract, you subtract the numbers. Really ain't that hard. Good job, you know how to do it.
Thank you, Mason. Here's the log marker.
So multiplying matrices, you can only do it when the number of columns in the first matrix and the number of rows in the second matrix are the same, which is m times n and n times p. So like, that's the columns and that's the rows. And so I think this is possible. And so when you multiply it, it's really stupid because it's more complicated than it should be. But either way, like when you want to find the dimensions of it, once you've multiplied it, it's the m and the p, so it's m times p. So this would be a 3 by 3. So when we do that, and so when you multiply it, you multiply the first row and the first column of, first row then first column of B, and that will be your first entry. So it would be 1 times 1 plus 4 times 4, and that's your very first entry out of the 9. And then your second entry is this. It's the first row, so it's the first row of this, but the second column, so it's the second column of B. So it's 1 times 2 plus 4 times 5. And now this one is the first row, so the first row of this, and the third column. So it's 1 times 3 plus 4 times 6. And then we just move to the next ones, like here, and it's the second row, so it's the second row, and the first column, so the first column. So it's 2 times 1 plus 5 times 4. Shut up, Brett. And then we'll just like
etc.
keep going. And now this one is the third row in the columns.
No commentary from a Let's Play or YouTube.
And this one's
Coach Essex or Coach Fish, can you come to the front office, please?
And now you just simplify this overcomplicated garbage.
But we don't need to do that,
Yeah,
that's
no,
good for
we're
now.
good.
Alright. So, go ahead and go to the next slide.
Right.
Okay, so an augmented matrix. You need a specific number set to do these. So you have your number set, which is 1, which is x minus 2y equals 7. And then we have, let's find it.
Emily Cobb and Riley Sunley to the office. Emily Cobb and Riley Sunley to the office, please.
-4. I had to copy an example because sometimes they don't work if you don't do that. So you're wanting to solve this. You can put it into a matrice by taking the number in front of each x or y coefficient, if you want to be fancy about it, and put it into a matrice. So you do 1, -2, and then this is the equal sign, and then 7. -3, 5, -4. Now you want to solve this using a matrice. What you have to do is you somehow have to take this at the bottom and make the x column, it needs the x and the y columns. You have to make its x column equal to 0 so you can figure out what y equals. So you can plug it into the top row so you can figure out your solution set. So what you want to do is you want to take the top row, so we have R1 plus R2, which means row 1 plus row 2 and you want to multiply the top row by whatever will make this number 0. So it would be 3. So now you take 1 times 3, which is 3 obviously, and you add these together. You don't change the top row at all, but that equals 0. And then you take 3 times -2, which is -6, making this number -1. And then you take 3 times 7, which makes that 21 minus 4, which makes it 17. And then you leave the top row the same. Now you know that -y equals 17. You divide by -1, and that means that y equals -17. So now you have your y value. And all you have to do is you plug it back into here to find out what the x value is. But since we're using matrices for some reason, we're gonna do it in the matrices. So you take what y equals, multiply it by the y column, so -17 times -2 is equal to, hang on, let's do some quick math here, 34, correct?
Yes.
So 34 x plus 34 equals 7. Now we subtract by 34 here, and that equals 27, -27. So now we know x equals -27. So now that we have the x and the y, all we have to do is put them into a solution. And that is your answer to solving an augmented matrix.
And or doing elimination or.
Yeah. This has been an amazing presentation on matrices. Thank you.